The trumpet, a brass instrument renowned for its versatility and brilliant sound, is a product of meticulous craftsmanship. Most trumpets are intended for beginning students and are hence kept at a reasonable price, but a professional trumpet can cost thousands of dollars. Even more expensive trumpets are made from solid gold and silver and can fetch an exorbitant price. But how did the trumpet industry begin, and how are these premium acoustic instruments made today? Established in 1842 by Adolphe Sax in Paris, the inaugural trumpet factory marked the beginning of a burgeoning industry. Swiftly, sizable manufacturers emerged in England and the United States. Gustave-Auguste Bessen's introduction of standardized parts in 1856 revolutionized trumpet production. In 1875, C.G. Kahn established a factory in Elkhart, Indiana, a city that remains a prominent hub for brass instrument manufacturing in the United States. Trumpets are predominantly made of brass, an alloy of copper and zinc. The composition of the brass alloy can vary, impacting the instrument's tonal qualities. The most common type of brass used is yellow brass, which is 70% copper and 30% zinc. Other types include gold brass, 80% copper and 20% zinc, and silver brass, made from copper, zinc, and nickel. The relatively small amount of zinc present in the alloy is necessary to make brass that is workable when cold. Some small manufacturers will use such special brasses as ambrons, 85% copper, 2% tin, and 13% zinc, for making certain parts of the trumpets because such alloys produce a sonorous ringing sound when struck. The bell is a critical component of the trumpet. Being an open end of the trumpet, it allows for the reflection and resonance of sound waves. This contributes to the rich resonant quality of the trumpet sound. The process begins with a flat brass sheet, which is cut into a fan shape. The flat fan-shaped sheet is then hammered around a pole. Where the tube is cylindrical, the ends are brought together into a butt joint. Where the tube begins to flare, the ends are overlapped to form a lap joint. The entire joint is then brazed with a propane-oxygen flame at 1500 to 1600 degrees Fahrenheit or 816 to 871 degrees Celsius to seal it. To make a rough bell shape, one end is hammered around the horn of a blacksmith anvil. The entire tube is then drawn on a mandrel while the bell is spun on the mandrel. A thin wire is placed around the bell's rim and metal is crimped around it to give the edge its crisp appearance. This thin wire helps keep the bell from collapsing. Then solder is forced into the rim. This increases the bell's responsiveness. Details like these can go a long way in determining how the bell ultimately sounds. The excess solder is scraped off using a scraper, and an abrasive sponge is then used to smooth out any scratches left by the sponge. Any solder bits still trapped in the rim are removed by further scraping. The bell is then filled with a soap and water solution and frozen at -49 degrees Celsius, freezing the water. The bell is then placed in a bending block. The ice provides crucial counterpressure, preventing the brass from buckling inward. The ice itself doesn't shatter under the pressure because the soap in the water makes it pliable. Bells may be manufactured in a variety of flare and bore sizes. The flare, which implies the widening of the bell at its end, and the bore size, which refers to the diameter of the tubing, influence the overall response and feel of the trumpet. A larger flare might contribute to a broader, more open sound, while a smaller flare can result in a focused and bright sound. Next up is the valves of the trumpet. These are complex parts that are made of several components including pistons, knuckles, and smaller tubings. These are crucial components that enable the player to change the pitch of the instrument. A standard trumpet has 3 valves, each corresponding to a specific length of tubing. When a valve is pressed down, it diverts the airflow through additional lengths of tubing, effectively changing the pitch of the notes produced by the instrument. The knuckles and accessory tubing are first drawn on a mandrel. The knuckles are bent into 30, 45, 60, and 90 degree angles, and the smaller tubes are bent using either the hydraulic or ball bearing method, annealed and washed in acid to remove oxides and flux from soldering. The valve cases are cut to length from heavy tubing and threaded at the ends. They then need to have holes cut into them that match those of the pistons. Even small manufacturers now have available computer programs that precisely measure where the holes should be drawn. The valve cases can be cut with drills whose heads are either pinpoint or rotary saws that cut the holes, after which pins prick out the scrap disc of metal. The knuckles, tubes, and valve cases are then placed in jigs that hold them precisely, and their joints are painted with a solder and flux mixture using a blowtorch. After an acid bath, the assembly is polished on a buffing machine using wax of varying grittiness and muslin discs of varying roughness that rotate at high speeds. The final part of the trumpet manufacture involves the manufacture of the lead pipe and the mouthpiece that is attached to it. The lead pipe serves as the initial entry point for air into the trumpet. Crafted from brass tubing, the lead pipe's design significantly influences the instrument's responsiveness and tonal characteristics. Manufacturers may experiment with different lead pipe configurations to achieve specific playing qualities. The mouthpiece, arguably the most personal component for a brass player, is usually made from brass, silver, or gold-plated brass. Its design and dimensions profoundly affect the player's ability to produce various tones. Solid brass bars are placed in a computer-controlled machine that meticulously shapes and cuts the bars into mouthpieces. The machine is programmed in such a way that each step, trimming the brass bars, shaping the rim, and creating the mouthpiece shank that fits into the lead pipe is precise within 1/1000th of an inch. Soldering is a crucial step in trumpet manufacturing as it involves joining the various components to create a seamless and airtight instrument. The soldering process demands precision, as any imperfections can compromise the trumpet's sound quality and playability. A high-quality trumpet may take 465 individual steps to put together and is composed of 120 separate parts. Once all the components are soldered together, the trumpet undergoes a series of inspections to ensure structural integrity and alignment. Skilled craftsmen check for leaks, correct valve action, and overall playability. Any imperfections are addressed, and the trumpet moves on to the next stage of the manufacturing process. After assembly, the trumpet undergoes various finishing processes to enhance its visual appeal and protect the instrument. This can involve polishing, lacquering, or plating depending on the desired aesthetic and the materials used. Some players prefer the natural patina that develops over time, while others opt for a polished and lacquered finish to maintain a pristine appearance. This is also the part of the manufacturing process where the trumpet may be engraved. Engraving on a trumpet serves various purposes. It can include the brand or manufacturer's logo, model name or number, and sometimes additional decorative elements. Engraving is often done on the bell of the trumpet due to its visible and flat surface. The most important feature of a trumpet is sound quality. Besides meeting extremely small tolerances, every trumpet that is manufactured is tested by professional musicians who check the tone and pitch of the instrument while listening to see if it is in tune within its desired dynamic range. The musicians test play in different acoustical setups, ranging from small studios to large concert halls, depending on the eventual use of the trumpet. Large trumpet manufacturers hire professional musicians as full-time testers, while small manufacturers rely on themselves or the customer to test their products. Trumpets are shipped either separately for special orders or in mass quantities for high school bands. They are wrapped carefully in thick plastic bubble packaging or other insulating material, placed in heavy boxes full of insulation, such as packaging peanuts, then mailed or sent as freight to the customer. At least half the work involved in creating and maintaining a clear-sounding trumpet is done by the customer. The delicate instruments require special handling, and because of their inherent asymmetry, they are prone to imbalance. Therefore, great care must be taken so as not to carelessly damage the instrument. To maintain the life of the trumpet, it must occasionally undergo repairs. Large dents can be removed by locally annealing and hammering, small dents can be hammered out and balls passed through to test the final size, fissures can be patched, and worn pistons can be replated and ground back to their former size. Well folks, that was it for the trumpet production, from the start of a brass sheet to this majestic instrument. If you're a fan of factory processes, we have plenty more where that came from. The modern harmonica as we know it today began to take shape in Europe during the early 19th century. Friedrich Buschmann, a German clockmaker, is often credited with inventing an instrument called the ora, which had free reeds like those in a harmonica. This instrument eventually evolved into what we recognize as the harmonica. But how do these instruments work, and more importantly, how are they made? There are many different kinds of harmonica, and they all work essentially on the same principle. When the player exhales air through the harmonica's chamber, air passes over the upturned reed, causing it to vibrate at a certain pitch.
When he exhales, the incoming air causes the downturned reed to vibrate. While playing, he uses his lips and tongue to cover the harmonica's other chambers, allowing air to flow through only the desired channels. Now that you know how the instrument works, we can get into the manufacturing process. The quality and characteristics of the materials used in a harmonica play a crucial role in its sound, durability, and overall performance. Manufacturers carefully select materials for various components of the harmonica. Reeds are the vibrating elements responsible for producing sound in a harmonica. They are typically made of brass or bronze, chosen for their resonance and durability. High-quality reeds are essential for achieving clear and consistent tones. The comb serves as the body of the harmonica, housing the reeds and directing airflow. It is commonly made of plastic or wood, with each material offering unique acoustic properties. Moisture resistance is also an important factor to consider on top of acoustic properties. You see, as air goes inside a harmonica, so does saliva. That is why they make the inner structure with a type of material that doesn't expand or smell with repeated exposure to moisture. The covers, often made of metal, protect the reeds and contribute to the harmonica's aesthetics. Aluminum, stainless steel, and chrome are commonly used materials for covers, chosen for their durability and corrosion resistance. Covers may also be gold or silver plated for some of the higher-end harmonicas. The comb forms the structural foundation of the harmonica, providing support for the reeds and guiding airflow. Manufacturing combs requires precision machining and meticulous attention to detail. Computer numerical control (CNC) machining is commonly used to shape the comb from solid blocks of plastic or wood. CNC mills and lathes precisely carve the comb's intricate channels and chambers according to the harmonica's design specifications. After machining, the comb undergoes finishing processes to smooth rough edges and ensure proper fitment of reeds and covers. Sanding, polishing, and buffing may be performed to achieve a smooth surface finish and enhance the harmonica's aesthetics. The process of making the reed starts with the manufacture of a reed plate that houses the reeds. A press stamps slots into a millimeter-thick brass plate that will form the reed plate. The plate will eventually go on top of the comb, its slots aligning with the comb's air chambers. Another machine cuts reeds from brass-based metals. These are specially produced to produce quality sound and be corrosion-resistant. Working one size at a time, they cut a batch from a few hundred reeds. They test a reed from each batch using a tuning machine, plucking it to see if it produces the correct pitch. The size and profile of a reed determine the note it produces. The longer it is, the lower the note, and vice versa. Next, the reeds are riveted onto the reed plate, one reed for each note. Consecutive reeds go on opposite sides of the plate. With this configuration, blowing air into the harmonica vibrates one reed, while drawing air out vibrates the other. They rivet each reed on one side of the plate. This fastens the reed securely at the bottom, leaving the other end free to vibrate. If necessary, they file the reed down so the slot doesn't obstruct its movement. Now a tuning specialist gets to work. She plays each reed on a plate and compares the tone to a perfectly tuned set of reeds for reference. If the pitch is off, she adjusts it with a bit of filing. Now for the two-piece cover that encloses these internal components. For standard models, the factory uses stainless steel starting with a sheet that's less than half a millimeter thick. The sheet goes through a press that has a series of dies that progressively stamp out the cover pieces, first embossing the artwork, then cutting the size, then forming the shape. Once the individual components are ready, they are assembled to create a functional harmonica. Assembly requires skilled craftsmanship and meticulous attention to detail. Each reed plate is carefully mounted onto the comb. Precision tweezers and specialized tools are used to ensure proper alignment and tensioning. The plate cover, which has been machined, shaped, and stamped with the company name and harmonica type, is attached to the reed comb assembly with screws or nails. This step creates a sealed chamber for the airflow and protects the delicate reeds from damage. After assembly, the harmonica undergoes airtightness testing to ensure that there are no leaks or obstructions in the airflow path. Pressurized air or smoke may be used to detect any imperfections that could affect the instrument's performance. Harmonicas produced through such a process may either be diatonic or chromatic. A diatonic harmonica is one of the most common types of harmonica, often used in blues, folk, country, and rock music. Diatonic harmonicas are designed to play in a specific key and have reeds tuned to the notes of that key's major scale. They typically have 10 holes and can play multiple notes when the player alternates between blowing and drawing air. Chromatic harmonicas, on the other hand, have a button-activated slide mechanism that allows players to access all the notes in the chromatic scale, including sharps and flats. This versatility makes them suitable for playing a wide range of musical styles, including jazz, classical, and pop. Chromatic harmonicas often have 12, 14, or 16 holes. In addition to pitch tuning, intonation adjustment ensures that the harmonica's notes are in tune with each other across the entire range of the instrument. This may involve tweaking the comb's airflow dynamics or repositioning individual reeds to achieve optimal intonation. Before a harmonica leaves the manufacturing facility, it undergoes rigorous quality control checks to ensure that it meets the highest standards of craftsmanship and performance. Each note on the harmonica is tested individually to evaluate its tone, volume, and responsiveness. Skilled musicians or automated testing equipment may be used to assess the instrument's sonic characteristics. The harmonica is subjected to further airtightness testing to verify that it maintains consistent airflow and pressure across all reeds. Any leaks or inconsistencies are identified and addressed before final inspection. The aesthetic aspects of the harmonica, such as cover alignment, surface finish, and engraving quality, are carefully scrutinized to ensure a flawless appearance. Once the harmonica passes all quality control checks, it is carefully packaged and prepared for distribution to musicians and retailers worldwide. The harmonica is packaged in protective cases or boxes to prevent damage during shipping and storage. Instruction manuals, cleaning tools, and other accessories may be included to enhance the user experience. That was all for how a harmonica is made. If you want to see more how it's made videos, check out our channel.